This is for Year 10 Methods Pathways. We're going to look at exercise 4.1, question 4. So we're looking at special products factorizations, and we're trying to solve for these factorizations. So we've got a bunch of equations that we want to solve. We'll have a look at question 4b just for as an example, just to get us started. So I've got x squared minus 81 equals 0. I know this is a dots pattern just by looking at it. So I can factorize the dots because I know this is a square term, and this is a square term, and in the middle we've got subtract. So it's a dots or difference of two squares. Okay, so factorizing as the dots, I go x minus 9, x plus 9, 0. Now, I then apply the null factor law because I know that null factor law states that if I got something times something equals 0, either the first something equals 0 or the second something equals 0. So I'm just going to solve for each of them. I can plus 9 on both sides. So I get x equals positive 9, or subtract 9 off both sides. I get x equals negative 9. So I've got two solutions. Now, the easier way actually is to rearrange to make x squared the subject. Okay. Now, why would I want to do that? Because it is, in fact, easier if I move the 81 to the other side. So it becomes positive 81. I can see that I can square root both sides. Now, be careful when you square root both sides, you always get a plus or minus solution. So you get x plus or minus 9 here. Okay, as you can see, these solutions are the same. Okay, and this is a lot quicker. Now, for something like question 4h, 6x squared minus 5 equals 0, you can use the dots factorization, but it's a bit more complicated because the 6 is not a square number. X squared is squared. So, and 5 not a square number either. So what you have to do is you have to go root 6x minus root 5, root 6x plus root 5 equals 0. So either root 6x minus root 5 equals 0, or root 6x plus root 5 equals 0 using null factor law. I move the root 5 to the other side, so you get x equals root 5, and divide both sides by root 6, root 5 over root 6, or x equals negative root 5 over root 6. Now, that's a lot more complicated than doing this. So we've got 6x squared minus 5 equals 0. I move the 5 to the other side. I want to isolate, so the goal is to isolate the x squared on its own. So in doing that, I move the 5 to the other side. I then divide both sides by 6, and I square root both sides, so plus or minus 5 root 6. Now, depending on, and really important, don't forget the plus or minus. So whenever you square root both sides, you always get a plus or minus solution. Now, what I want to emphasize is talking about surds. So if we got root 5 on 6, that's the same as root 5 on root 6. Sometimes the textbook rationalizes surd, so you've got to be mindful that you'd have to do that. So to rationalize the surd, you times both sides by 6 on root 6. Rationalizing just means you don't want the denominator to be a surd. So that'll be root 30 divided by 6. I'm not sure whether the book does it like that, so I'm just showing you how this is rationalized in case that's what has in the answer. So hopefully that helps. So questions like 4a, 4b, 4c, even 4d, and 4e and 4f are doable because they're all square numbers, so you can do a dots factorization quite easily. But even easier is to rearrange the equation so that x squared is subject, and you can take the square root of both sides to get the answer. So hopefully it helps.